We are going to do another example of factoring. So let's start with this equation. We have 17x squared minus 11x plus 2 equals 2x squared. So we need to put this equation into standard form, so let's subtract the 2x squared from this side, subtract it on the other side as well. We are left with 15x squared minus 11x plus 2 equals 0. So let us assign values to our coefficients. A in this case equals 15, B equals negative 11, C equals 2. Make our factor map. Okay. So in the top we're going to have A times C, so that's 15 times 2 is going to be 30. The bottom we have B, which is negative 11. So we're trying to find the factors of 30 that add up to negative 11. So let's see, 1 times 30, no, that doesn't work. 2 times 15, no, that doesn't work. Let's do 6 times 5, that one will work, okay? So let's do negative 5, negative 6. You just copy up top, okay? And let's split our B term. We have 11x turns into minus 5x and minus 6x. Then we just drop down the other two terms. We are left with 15x squared minus 5x minus 6x plus 2. So let's group our two factors together. And we are going to want to find the greatest common factor of 15x squared minus 5x and negative 6x plus 2. Okay? So the greatest common factor of 15x squared and 5x is going to be 5x. Once we simplify this, that is going to be a 3x minus 1. Okay, great. So we need to factor something out, so that way negative 6x plus 2 equals 3x minus 1. So let us factor out a negative 2, and that will leave us with negative 2 times 3x minus 1. Okay, so this is going to be a term, and then these two are going to be a factor. So we have 3x minus 1, and then we're going to make the second factor with 5x minus 2 times 5x minus 2. Set both equations equal to 0. We get 3x minus 1 equals 0. 5x minus 2 equals 0. Solve them one at a time. Plus 1. We get 3x equals 1 divided by 3 divided by 3. X equals 1/3. Now on this side we have plus 2 plus 2. 5x equals 2 divided by 5 divided by 5. X equals negative 2. Oh, that's a positive. I'm so sorry. X equals positive 2 over 5. And those are our two answers. All right. Let's do another problem. Okay. So up here, we have the problem 3x squared equals 5x. Now, this is definitely an unfamiliar form for you, right? Usually we have ax squared plus bx plus c. So where's the c? You know, the bx is on the wrong side of the term. So let's make sure that we put this into whatever kind of standard form that we can find, and that's going to be minus 5x, 3x squared minus 5x equals 0. Okay? So we need to make a c, so that way we can do our standard form. So I made a c right here. I just added 0 because it doesn't change the value of the equation. It just kind of acts as a placeholder, so I can use the same method that I've been using, okay? So I'm going to assign values to the variables a, b, and c. A is 3, b is negative 5, c is 0, okay? So now we are going to make our factor map. B goes down here. A times C goes up here. That's going to be 0. So what factors of 0 add up to negative 5? And that is going to be negative 5 and 0. So we'll just rewrite these up here. We're going to split our b term into negative 5x and 0x. Okay? Bring down the constant. Bring down the variable. We have 3x squared minus 5x plus 0x plus 0. So we're going to group our factors. 0x plus 0 is 0. So we are just going to forget about this guy over here. Now we have 3x squared minus 5x, which is exactly what we started with. It's just in a way that we understand how we got there. So, in all honesty, if you wanted to solve this in a shorter way, why don't I just show you that afterwards, okay? All right, so we have 3x squared minus 5x, okay? And we can only factor an x out of that, so we'll have 3x minus 5, all right? And then we have our little x over here. So x has to equal 0, because if this is supposed to equal 0 and 3x minus 5 is going to be our other root, this needs to be equal to 0 in order to make the equation equal to 0, okay? So we can assume that x equals 0 for one of the roots, and then for the other root, let's do 3x minus 5 equals 0, and we'll solve for that, okay? Simplify. X equals 5 over 3, x equals 0. Okay, those are our two roots. Okay, great. Let's do another problem, okay? All right. So, what if we are given a problem that looks like this? Okay, well, we know it's a quadratic because it has the square root sign right here, but everything else is a little unfamiliar, right? There's no b term, the c term is on the other side of the equation, so it's just a little different. But we call a problem like this solving the difference of two squares, okay? But you would solve it in kind of the same way as you would in any other quadratic that you're trying to factor. I'm going to do it that way first, and then I'll show you a shortcut, okay? So you're still factoring the quadratic, but you can skip a few steps, okay? But here we go. So if we are solving in the traditional sense, in the way that we have already learned how to solve, let's do it this way, okay? So we have 144b squared. We're going to minus 36 from each side, okay? So that way we can put it in some resemblance of standard form, okay? So let us add in a b term like we did on the last problem. So that way we can factor it the way that we know how to factor, okay? Assign variable, assign values to our coefficients. A is 144. B is 0. C is negative 36. So let's make our little factor map. Oops. Okay, so B, down here, A times C, 144 times negative 36, that is going to give us 5184, okay? Now, what we should be able to notice is that 51, oh, this is a little messy, hold on. What we should be able to notice is that 5184 is a perfect square. So 72 times 72 equals 5184. Therefore, the two factors of 72 that when added equals 0, are going to be negative 72 and positive 72. Okay? So now we will just split the b term as we ordinarily would. And we're going to split it into 72x and negative 72x. Bring this down. Okay, so now we group and we get our two factors that we need to factor. Our two factors that we need to find the GCF of, okay? So we can factor out a 72b and we'll get 2b plus 1. And then on this side, we can factor out a negative 36, and we'll get 2b plus 1. Both of these match, we're in good shape. Okay, so our first term is going to be 2b plus 1, and our second term is going to be 72b minus 36. Okay, so let's set these both equal to 0. B equals negative 1/2. And then on this side, we're going to do (72b equals 36 divided by 72 divided by 72). 36 is half of 72, so I already know without having to reduce that this is going to be 1/2. So we have b equals negative 1/2 and b equals positive 1/2. So I mentioned before that I could show you a shortcut in order to find this. So I'm going to show you the shortcut, okay? All right, so let's start again. We have 144b squared equals 36. So let's say that you are comfortable with square roots and you think that you could solve this. There's no b term, so there's no third thing that you need to find in order to factor out. So in essence, if you are comfortable with square roots, I would just assure you to solve it like this. Now, this type of problem is the only problem that we can solve this way. You can't solve regular quadratic equations like that because there's that b term, that third term. But since these are 36 and 144 are both perfect squares and there's no b term, you can solve it this way, okay? So the 144 cancel out. We get b squared equals 36 over 144. So the opposite or the inverse of exponents is square roots. So we're going to square both sides, and we get b equals plus or minus 6 over 12, which reduces to b equals positive and negative 1 over 2. So therefore, b equals positive 1/2, b equals negative 1/2, and we got to the answer in 1/3 of the time.